Okay, I alluded to this earlier that we have to be careful of transition metals. Transition metals, you may want to go back and check. Do you know where they are on the periodic table? They can have more than one charge, and we call that multiple oxidation states. And I gave you the example before that copper is a 1 plus or a 2 plus. For example, iron could be a 2 plus or a 3 plus, and we'll give you a chart in which you can start to memorize which elements have multiple oxidation states and how do we use them. Even though you find silver and zinc, they're transition metals, silver is always +1 and zinc is always +2. Those are important to keep note of. Well, how do we name this? To keep these separated from each other, we can't just use the phrase copper, just like we did before with aluminum or sodium or magnesium. To keep these separated from each other, we give them a Roman numeral. We call them copper 1 or copper 2. So when working with transition metals, if they have, and I probably don't have to do this, but I will, Roman numeral 1 is copper 1, Roman numeral 2, copper 2, and then iron 2. And it's not that every one has 1 or 2 or 3. It depends on the nature of the atom itself as to which levels of oxidation states it has. So in this case, it would be iron 2 or iron 3. And so you treat these as you would any other element that doesn't have multiple oxidation numbers. When you crisscross, it's just that if we were to write the names, you're going to need the Roman numerals in the name. Let me state that again. You don't need to put the Roman numeral in the formula, just in the name. For example, iron 2 chloride would be Fe 2 plus, because the iron 2 is telling me that. Chloride is 1 minus. Crisscross method tells me that it would be FeCl2. Crisscross method. And notice that the Roman numeral is only found in the name, not in the formula. If it was iron 3 chloride, it would be FeCl3, and then I would write it as iron 3 chloride. Let's try lead 2 fluoride. Lead symbol is Pb. I don't have to memorize what the charge is because it tells me right there. The Roman numeral gives us the charge on the cation. Fluoride's in the halogen family. Halogens, one away from the noble gases, they form a 1 minus. Crisscross method. Balanced charges is what we're doing here. And my formula for lead 2 fluoride comes out to Pb F2. And you do the same thing if you're working with a polyatomic ion. Maybe I want iron 3 sulfate. Well, I've got an 8 here, so that's one of my polyatomics. Fe3 plus from the Roman numeral. Parentheses, because I'm dealing with beast. SO4 2 minus. Crisscross method tells me I'm going to need 2 things that are 3 plus, and 3 things, 3 species that are 2 minus. That gives me a plus 6. That gives me a minus 6. Again, they're going to add up to 0. My formula for iron 2 sulfate is Fe2 SO4 3. Now sometimes the charges can be hidden. For example, if I have lead, and this is kind of a big statement here, lead 2 oxide. Make sure we've got that. That's lead 2 oxide. Pb 2 plus oxide ide monatomic anion. When I crisscross these, it would come out to Pb2O2. By definition, if an ionic compound is able to be reduced, we can reduce it. So I can divide both of these by 2, and the formula would come out to be lead, just PbO. That's still lead 2 oxide. The reason that it's lead 2 oxide is we let the charge of the anion tell us what the cation is. I know that oxygen is always 2 minus. Lead can be actually Pb2 plus, you'll see the list, and it can be Pb4 plus. Well, in this case, if it's a 1-to-1 ratio, if I have one thing and one atom, the only possibility that it could be is 2 plus. So it's been reduced, so we have to watch for that.